Physics part 97. This means that no energy is lost in the permanent deformation of the colliding bodies or as heat and sound. There is a transformation of energy during the collision. While the colliding bodies are in contact, some of the kinetic energy is transformed into elastic potential energy. But as the bodies separate, it is transformed into kinetic energy again, using the same notation for the masses and speeds of the colliding particles as in the section. The total kinetic energy of the particles before collision is half m1 into u1 whole square plus half m2 u2 whole square. The total kinetic energy afterward is half m1 v1 square plus half m2 v2 square. If the collision is elastic, the kinetic energy before collision is equal to the kinetic energy after collision. Half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Note that because the energy is a scalar, the direction of the motion of the particles are not indicated by signs of the various terms. In solving problems of elastic collisions, this equation is useful because it gives another relation between masses and velocities. In addition to that obtained from the principle of conservation of momentum, when the velocity directions are as defined in the figure, application of the two conservation conditions shows u1 plus u2 is equal to v1 plus v2. For a perfectly elastic collision, that is the relative speed of approach, u1 plus u2 is equal to the relative speed of the separation, v1 plus v2. Note that this useful relation applies only for a perfectly elastic collision. Elastic collisions occur in the collision of atoms and molecules. We shall see in chapters that one of the most important assumptions in the kinetic theory of gases is that the collision of the gas molecules with walls of the container are perfectly elastic. However, in large scales collisions such as those of billiard balls, collisions cannot perfectly be elastic. The click of a billiard ball on impact indicates that a very small friction of the total energy of the system has been transformed into the sound. Nevertheless, we often make the assumptions that such a collision is perfectly elastic. Collision in which the total kinetic energy is not the same before and after the event are called inelastic. Total energy must of course be conserved, but in an elastic collision, the kinetic energy that does not reappear in the same form is transformed into heat, sound, and other forms of energy. In an extreme case, all the kinetic energy may be lost. A lump of modeling clay dropped onto the floor does not bounce. All the kinetic energy it possessed just before hitting the floor has been transformed into the work done in flattening the lump, a much smaller amount, into the sound energy emitted as a squash. Although kinetic energy may or may not be conserved in a collision, momentum is always conserved, and so is total energy. The truth of this statement may not be entirely obvious, especially when considering examples such as the lump of modeling clay which was dropped onto the floor. Surely the clay had momentum just before the collision with the floor, but had no momentum afterwards. True, But for the system of the lump of clay alone, external forces, attraction of the earth on clay, and the force exerted by the floor on the clay impact were acting.